Hey, happy almost Halloween, everybody. What do you call two witches who are roommates? Broommates. Broommates. All right. All right. Today you're going to need this paper. It's going to say, if I can get it there, it's going to say 3.1D. These are part two of your chemical property notes or your properties. Right, first one was physical properties. Now we're going to chemical properties. You'll pause the video a few times as you're working. It's a little bit longer because I wanted to show you some videos to give you some real life examples. And here we go. All right. A chemical property is a property that describes the ability of a substance to change into a new substance that has completely different properties. So you'll pause and you'll write this. And here's my example for you. As you can see, these marshmallows here are chemically changing. They are turning into a brand new substance, which is burnt marshmallows, but it's a brand new substance. They've completely changed, and that is a chemical change. So once again, you can see that they've gone through a chemical change. It means that what you start with, the substance, is totally different than what you finish with. All righty. Flammability. Flammability, as you're going to write notes, is your ability to burn. Some examples are hydrogen and oxygen. And what is interesting is that different liquids or different elements burn different colors. You can see that some burn orange, some burn red, some burn green, some burn purple, and different elements can burn different colors. And that gives scientists a clear view on what it is that they're working with, because the idea of properties is that you can identify the substance that you're looking at. And flammability is one of them. Now, some are going to react with oxygen or reactivity with oxygen. That means it has the ability to react chemically with oxygen. It's going to start as one thing and it's going to turn into something totally different. We call this process oxidation. And make sure to pause while you're watching this. Here's an example of the Statue of Liberty. And this is what we call a time lapse. You can see that it starts green, or it starts brown. It started copper, and then over the years, it has turned green because of the oxidation. And this is in New York City. And that is an example of reactivity with oxygen. Sometimes cars can react with oxygen. Like I said, copper masks, and of course, the Statue of Liberty can react with oxygen. All right, reactivity with vinegar and acids. Vinegar is an acid. We'll talk about that in class. And it has the ability to react chemically with vinegar. For example, baking soda reacts with vinegar and it releases carbon dioxide. And in this case here, you've got this giant balloon that has baking soda in it, and it's pouring into vinegar, and the reaction is causing the molecules to start crashing in together and colliding, and they are creating this giant balloon. You can say it's creating all this space because of the chemical reactions. And so vinegar is one thing, baking soda is another pure substance, and together when you mix them, you get something completely brand new, which is carbon dioxide, which is why it has gone through a chemical change, and it is a reactivity with vinegar is a chemical property. Iodine is a liquid, and it has the ability to react chemically with iodine. For example, we're going to be putting some solids into some liquids with iodine, and depending on what the solid is, the iodine will turn different colors. Sometimes it'll turn a brown, sometimes it'll turn a murky white, and sometimes it'll turn either purple or black. So objects can be reactive with iodine. Scientists use this so they can identify what is and what isn't. Because starch reacts turning brown. If something turns brown, they know it's a possibility that it's iodine. If it doesn't turn brown or turning brown to a purplish color, if it doesn't turn to that purplish black, that they know it's not starch. Another way to check for a chemical reaction is reactivity with cabbage indicator. Yes, cabbage. We're going to be boiling some cabbage. We'll use cabbage indicator. And when you put the cabbage with a particular liquid, then you can tell if the liquid is an acid, or if it changes these types of colors to a green, we know that it is going to be alkali, which is also known as a base. So we'll look at reactivity with a cabbage indicator. So we'll boil cabbage and we'll get a different color water from it. All right. Identifying substances with properties. So we've talked about how each pure substance has a unique set of properties that can be used to identify it. Some react with water, some are flammable, some react with vinegar, some react with iodine. In this video, you're going to try to guess, and this is at the bottom of your paper, hydrogen and helium. You're going to guess which is the balloon that has hydrogen and which has helium. Hydrogen is a flammable gas. Helium is not. So let's see. Oops. Hello, everybody. There we go. So that is your pink balloon. Do you think that that is full of hydrogen, or do you think it's full of helium? And then go ahead and explain why you think so. Make sure to pause the video. And now let's have a look at our other balloon. So this is our red balloon. So based on that, and you can rewind and look at both of them, do you think the pink balloon is hydrogen or do you think it's helium? You'll fill in this bottom of your page that's right over here. And the last one that I thought I'd show you just for fun today is going to be how some elements react with water. Sodium, not salt, but actual sodium, reacts violently with water. So check this one out. Yeah, that was pretty amazing. And so what they did is they took sodium, which reacts with water. It's not salt. Salt is NaCl. It's sodium. And the sodium react with the water there and did some damage to the toilet. You guys have a great day. Thanks for tuning in.